So, sigma notation. Mathematicians have a way of making things look very complicated that aren't really that complicated. So stick with me. We're going to use this Greek symbol, sigma. It's capital S. Kind of looks like an E. But this right here is going to tell you where to start. I think it's called the index. And this right here is going to be where you finish, or where you stop. And then this is going to tell you what your rule is, or your nth term. You're going to plug all of these numbers in, starting with 0. You're going to plug in 0 here, plug in 1, 2, 3, 4, all the way up until you get to k. So I think the easiest way to demonstrate this is by actually doing it. So if a question said, evaluate this, first off, the sigma is telling you to add everything up. And so we take 1, because it's our starting point, and we plug it in. So 3 times 1 minus 1. That's your first term. So 3 times 1 is 3, minus 1 is 2. And then we add to that 3 times 2 minus 1. 6 minus 1 is 5. Plus 3 times 3 minus 1. 9 minus 1 is 8. And 3 times 4 minus 1. And that's 12 minus 1 is 11. So this is called a series because we're adding up a sequence of numbers. This would be a sub 1, a sub 2, a sub 3, and a sub 4. If we add them together, we get 10, 21, 26, and this would be the sum of the series. So let's practice putting some of these in sigma notation. So we need right here. And notice how we used n equals and n equals up here. Now, because we were using n as a variable, and we said 69 plus n was our nth term equation here. Let's start at n equals 1 and go to, this is the first, second, third, fourth, fifth term, so we're going to go through 5 and stop at 5. And that represents that. And then we had our other one, and we said whatever n is squared divided by 100, and we're going to add up all of the days from n equals 1 all up to day 5. And that's what sigma notation looks like. Now, obviously it's not hard once you have the equation, so it's harder to come up with that nth term equation, so that's what we had to do last time. So let's practice how you kind of do that. So, what you want to do is, one thing I do is I lay down 1, 2, 3, what terms we have and how we get there. Another thing I look at is, what do you add every single time? Do you add something every single time, or do you multiply everything every single time, or something squared, cubed, so on? So we're adding 2 every single time here. So if you want to think of a 2 as a slope, and so it'll be 2 times n in there anytime, because it's kind of like slope. And so now you notice, well, if first term, multiply n times 2, we get 2. 2 times 2, 3 times 2, 4 times 2, 5 times 2, 6 times 2. And so that is our nth term equation. We start at 1 and end at 6. Let's try another. So, 1, 2, 3, 4, 5. So this one takes noticing, okay, what do 3, 9, 27, 81, 243 have in common? Well, if you keep multiplying by 3, or you see all of these are powers of 3, this is 3 to the first power, 3 to the second, 3 to the third, 3 to the fourth, 3 to the fifth. And so really it's just 3 to whatever power n is. This is what we call a geometric sequence. It's going to have a common ratio. But so when you repeatedly multiply by 3, that produces an exponent. And we're going to start at n equals 1, and we're going to go to the 5th term. Alright, let's try another. Getting a little more complicated. So first term, second term, third term, fourth term. So on top, you get 1, 4, 9, 16. Notice how 2, 3, and 4 are related to there. On top, we get whatever n is squared. 1 squared, 2 squared, 3 squared, 4 squared. And then on the bottom is always 1 more than the top. So the bottom has to be n squared plus 1. So we start at 1, and you can always double check it. 1 squared plus 1, 1/2. 4 squared is 16, 16 plus 1 is 17, so it works. And we're going to go to infinity because we have an infinite sequence. And 5, 6, 7, 8. So this is kind of like our slope here. We're adding 1 each time. Plus 1. Plus 1, plus 1, plus 1, so on. And so we're going to have just an n, and in order to, when we plug in 1 to get 5, I need to add 4. Because 1 plus 4 is 5. 2 plus 4 is 6, 3 plus 4, 4 plus 4. And so we're going to start at n equals 1 and end when this number plus 4 equals 28. So at 24. And there we have it. So we had to find our ending point there. We couldn't just count. And we'll pick up next with how to add up all the integers from 1 to 100.